Okay, I decided to pre-write these questions. So you could pause it, and what we have here is 9 people are randomly lining up. 9 people randomly. It's important. For all of these, it's a random process, so we're trying to figure out the probability. So 9 people are randomly lining up for a photo. What's the probability that Felix is on the far left and that Josh and Mackenzie are standing together? Okay. So this is a question that is actually surprisingly challenging. So what we have is, we have our NS, well, that's not that challenging. 9 people lining up, so it's just 9 factorial. Well, that was very exciting. Now, for our NA, we want so first we have Felix staying on the far left, and that spot's really out. So now there's 8 spots left. But there's also a JM block, and that's 1, 2, 3, and then 6 other people. 1, 2, 3, 4, 5, 6. Not drawn so well, but so Felix is fixed. JM are together. 1, 2, 3, 4, 5, 6. So that's going to be a total of 1, 2, 3, 4, 5, 6, 7. 7 factorial. So there's going to be 7 factorial ways to have that. Also, of course, we could have Felix on the left, and it could also be, the block could be an MJ block, and there'd be another 7 factorial ways of doing that one. So overall, the NA is going to be 2 times 7 factorial. Putting it all together, the probability of getting what we want is going to be 2 times 7 factorial divided by 9 factorial. 2 times 7 factorial equals divided by 9 factorial equals. And I got 2.78%. I like to keep 3 significant digits. 2.78%. That was number 4. Obviously, a harder version of this, I'm not going to do it right now, would be if I asked what's the probability of Josh and Mackenzie, of Felix being on the left and Josh and Mackenzie not standing together. That could be fun. Example 5. 7 people randomly line up for a photo. What's the probability that Ivy is on the far left, but Kirsten is not on the far right? Okay, so yeah, this is pretty straightforward, as is often the case. So we want, 2, 3, 4, 5, 6, 7. We want Ivy on the far left. And there's 6 spots, so there's 6 factorial ways of Ivy being on the far left. Of those, though, of the ones with Ivy on the far left, there are a bunch that have Kirsten on the far right. That says far, on the far right. And if the other people are randomly going, so there's 6 factorial ways for Ivy to be first, but of those 6 factorial ways, or to put in numbers, there's 720 ways for everyone to line up, but 120 of those involve Kirsten doing that. So my NA is actually going to be 6 factorial minus 5 factorial. And putting it all together, we get that the probability is going to be 6 factorial minus 5 factorial, all divided by 7 factorial, which is 11.9%. That should be 11. I'm going to rewrite it 11.9%, or 0.119.